welcome back to our channel Euclid Mathematics. We have started lecture series on a ring theory and other subject too. In my today's video, I will explain to you all one of the question. It is very much important on ring theory that we have to show that a certain group it satisfy the all properties for ring. Okay, now let's get started our today's lecture. I will explain to you all how the solution it look like. First of all, we have to recap some of the properties from ring theory. Now first property, it says that R under addition is a commutative group. Okay, if we have to show any group or R under addition dot it is a ring, then we have to show R under addition that is R under addition. Okay, this it is a commutative group. That means we need to show closeness, associative, then identity element, inverse element, and commutative property. Okay, so if this hold, then move for further. R dot it is a semi group. Okay, under multiplication it need to be a semi group. Semi group means under multiplication it need to satisfy closeness property and associative property. These two property need to satisfy it here. And now third one, left and right distribution law. Okay, so these properties need to satisfy, so in order to show our group is ring or not. Okay, now let's get started our today's example. I will explain this property in detail with the example. Here we all can see our example. It says that we have to show q, it is a rational, cross singleton 0, q cross 0 under addition dot means multiplication is ring, is form a ring. Okay, so that q cross singleton 0 under addition multiplication it forms a ring. That means it satisfy the all property which we learned in our previous lecture, all properties from a ring. Okay, now the first property, it says that we have to show our q cross singleton 0 under addition dot. Okay, with respect to this q cross singleton 0 under addition, it is a commutative group. Okay, but to prove this commutative group, we need to know the elements which belongs to our set. Okay, so which type of the element it belongs to our set? So we have the q cross singleton 0. Okay, so q means you have non-zero element here, like a belongs to q, or you may take any element. So I consider a from q, and 0 means it contain only singleton 0. That means it is having two element like order pair form a 0. Okay, a and 0, and we have to show such a type of element hold commutative property. Okay, commutative group. Now let's go for the commutative group. We have first property for closeness. Okay, now I selected here two elements like a q cross singleton 0 at a0 from a belongs to q, and second element b0 which belongs to q cross singleton 0. Okay, so to show closure property, okay, in order to show closure property, so we need a two elements. Okay, we need a two elements, and we are trying to prove their addition it is also in our group. Okay, so if a belongs to q and b belongs to q, then we show that a plus b also belongs to q. Okay, so this is the closeness property of our commutative group. Okay, so show that this property hold. So x plus y, we need to show this is also belongs to q cross singleton 0. Okay, so x plus y means add their corresponding element of order pair. So a plus b it is here, and 0 plus 0 it is here. Okay, so a plus b comma 0, how we add to order pair? We take their corresponding elements, we add their corresponding elements like a plus b, 0 plus 0. Okay, so similarly I did it here. So a plus b comma 0, and we know that if we take the addition of a two element, if a and b from the q or rational, their addition also it goes to the rational. So a plus b it is goes to already in rational, and 0 it is already there in singleton 0. So that's why x plus y it is goes to q cross singleton 0. So closeness property hold here. Okay, it's easier that easily we can show that closeness property hold. Okay, now next task is here to find out the associative property. So if this property hold for a two element, obviously this property hold for three element too. So x plus y plus z, three element, how it comes? X plus y plus z as a plus b plus c. So surely this hold for the three elements also. So x plus y plus z, which is equal to x plus y plus z, which is equal to x plus y plus z. Now remember, we are doing for commutative group under addition, so we are taking under consideration only addition property. Okay, so here second property easily hold here. So now identity element. Okay, what is the identity element under addition? So under addition 0 is the identity element, and under multiplication 1 is the identity element. Okay, so under addition 0 is the identity element, means 0 belongs to q and 0 belongs to 0. That means 0 0, these two elements are identity element here in the form of order pair, which is belongs to our required q cross 0 group. Okay, so if it is there, that means identity element is also there. Okay, so it shows that involvement of identity element. Okay, So if we add x plus identity or any element plus identity, we'll get that element itself. So x plus identity, which is equal to identity plus x, which is equal to x. Okay. So this is our identity property for our group. Okay. Now about the inverse. Okay. So inverse of our group. So inverse means if we add any element to that inverse, we will get the identity element. So identity element means we want the 0, 0 as identity element. So here for the inverse, I consider x as a0, which is from q cross singleton 0. Okay. A, it is from q and 0 it is from 0. So I want the inverse for a0. So obviously we know that we want the order pair. Here when we add that into the a0, we'll get the identity element as a 0, 0. Then only one possible option it is there, minus a and 0. Okay. When we add a to minus a, we'll get the identity element. So we got the negative of a, which is also from rational. It is from q. So if negative element it is also there, that means x plus minus x plus x, which is equal to 0, 0. And x is our required element a0, and minus x, it is a minus a0. Okay. Minus x is a minus a0. So involvement of inverse it is also there. So the property of inverse it hold. Okay. Now next we have to show commutative property like x plus y, which is equal to y plus x. Okay. Now x I consider a0, y consider b0. Okay. And these two elements which is from the q cross singleton 0. Okay. Now show that x plus y, a plus 0 plus b plus 0. So a plus b comma 0. So a plus b comma 0. And a plus b we can write as a b plus a, like a 7 plus 2, which is equal to 2 plus 7. The answer it will remain same and it goes to the rational itself. Okay. So that's why the addition remains same. So a b plus a, which is equal to 0 plus 0. 0 can be written as 0 plus 0. So b plus a. Now expand these two values. So b comma 0 here plus a comma 0. So y plus x. So here I shown here x plus y, which is equal to y plus x. So b0 is the value for y and a0 is the value for x. Okay. So or other way you may find first of all the value for x plus y, again find out the value for y plus x, and prove that these two values are equal. Okay. So it is easier to show. Okay. If x plus y, which is equal to y plus x hold, so what it shows that? It shows that the given property hold abelian group. Okay. That means our group is a abelian. So q cross singleton 0 under addition is a abelian group. Okay. Now next property it is remaining here to prove that our group q cross singleton 0 under multiplication. Now we have here under multiplication is a semi group. Now let's prove how the property of a semi group it holds for our group. Now for closureness, take any element, any two element from our group. X is a0 from q cross singleton 0 and a belongs to q, and y b0 belongs to q cross singleton 0. These two elements from our group, and b it is from the q. Okay. And show the closureness property for multiplication. Okay. So for semi group we show the closureness property. Okay. A belongs to q, b belongs to q, and their dot product it is also in q. Now find out their dot product. A dot b, it is here as it is 0 dot 0, it is 0. Okay. So multiplication of a two order pair means we have to multiply their corresponding element always. Okay. So a dot b and 0 dot 0, it is 0. So a dot b as it is 0 dot 0, 0, which is also belongs to q minus singleton 0. Okay. So which gives their multiplication, it also goes to q cross singleton 0. And now second property which show that we show it for three elements like x dot y dot z, which is equal to x dot y dot z. Now you may consider z as a c0 from q cross singleton 0 and substitute these values here. You will get the all these two sides equal, because commutative if hold for two elements, surely it hold for three element too. So it hold for three elements like a dot b dot c comma 0. So a dot b dot c it goes to the q itself. Then x dot y dot z it also goes to q itself. Okay. So second property for a semi group under multiplication, it hold for our ring. Now let's go for the last property. It is only the remaining distributive law. Okay. If the distributive law holds, then we say that our group is a ring. Okay. So it hold for all the property of a ring. Now here left right distributive law. Now left and right prove these two distributive laws here. X dot y plus z as a x dot y plus x dot z, and x plus y dot z is a x dot y x dot z plus y dot z. Okay. Prove these two property hold for distributive law. Okay. Now from distributive law, okay, all x y z take it from the q cross singleton 0. Okay. And surely you will get the as it is answer. Okay. So that means our example like our group q cross singleton 0, it hold the distributive law too. Okay. So you may take the any element like I consider a0 b0 and c0. Okay. So put it here a dot a comma 0 dot b comma 0 plus c comma 0, which is equal to a comma 0 dot b comma 0 plus a comma 0 dot c comma 0. The both sides it obviously comes equal. Okay. So it is quite easy. Just easier calculation. We have to follow the operation between two order pairs only. So if all the properties hold here, then we say that Q cross singleton 0 under addition and multiplication is a ring. Okay. So what I have done here, I prove first of all here the Q cross singleton 0 under addition is a group. Then thereafter I proved the Q cross singleton 0 under multiplication is a semi group. And at the end I proved here they hold right distributive law. Okay. So if it hold for three property, then we say that our Q cross singleton 0 under addition dot is a ring. Now similarly you may try for R cross singleton 0, complex cross singleton 0, Z cross singleton 0, Z cross Q cross singleton 0, Z cross 0 cross singleton 0, and at the end R cross complex cross singleton 0 under addition and multiplication. It satisfy the properties of a ring. So this is for your homework. It is quite easy. Take the counter element, counter example, and prove that our ring group properties of a group fold and our given example satisfy all the properties of a ring. Okay, so that's it for our today's example. Okay, so in my today's example I explained to you all here the one of the example from ring theory. Okay, how we can prove Q cross singleton 0 under addition is a ring. Okay, so we need to satisfy only three properties. Okay, it's quite easy to understand. So even after, if you found anything difficult, let me know in a comment section. I will come up with the similar videos. Okay, so thank you everyone. Thank you for my today's lecture.